Assalamualaikum warahmatullahi wabarakatuh. Hari ini kita pergi ke lecture 2 Fundamental of Proof. Okey. Okay, for lecture content, first I will introduce rule of inference. There are introduction there, rule of inference for proposition logic, then using rule for inference to build argument. Then number 2 is introduction to proof, which is introduction and basic proof strategy. Okay, in this lecture, there's a lot of statement that we have to determine and less calculation for numbers. Okay. For an introduction, proof in mathematics are valid argument that establish the truth of mathematical statement. Okay, every mathematical statement we have to determine whether there is a valid argument or not. By argument, we mean a sequence of statements that end with a conclusion. Okay, every argument must have a sequence of statement, which is in our argument there is statement 1, statement 2, and it will be end with the conclusion. Akhirnya mesti ada kesimpulan. Okay, by valid we mean the conclusion must follow from the truth of the preceding statement or premise of the argument. Okay, so sekarang kat sini valid. Valid tu maksudnya kita ada premise 1, premise 2, semua tu must be valid. Maksudnya true, then the argument must be, the conclusion must be true. That is an argument is valid if and only if it is impossible for all premises to be true and the conclusion to be false. Okay, adalah impossible for all premise to be true. Okay, maksudnya and the conclusion to be kalau macam semua argument dia true dan conclusion dia tiba-tiba false, memang impossible lah to deduce new statement from statement we already have. We use rule of inference, which are template for constructing valid argument. Okay, there is rule. We have to follow the rule to construct valid argument. Okay, rule of inference are basic tool for establishing the truth of statement. Okay, for example 1. Consider the following argument involving proposition. Okay, this first argument. Okay, first statement is if you have a current password, then you can log on to the network. Okay, which is if you have a current, this is the premise 1. First sentence is the premise 1. If you have a current password, then you can log on to the network. If we think, maksudnya kalau kita fikir, first ayat ni logik kan? Jika benar kita ada password true, then you can log on to the network. Okay, true, then true must be true. Remember the truth table that we learned last week? Okay, then ayat seterusnya, you have a current password. Dan orang tu ada the current password. Then as a conclusion, we can conclude that you can log onto the network. Okay, kamu nampak tak? Benda ni kan biasa kamu guna dekat dalam when you develop a rule for your system. Contohnya, okay, orang tu dia contohnya sistem untuk pendaftaran pelajaran kan. If orang tu CGPA dia atas 2, then dia boleh daftar 18 kredit. Macam tu. Nampak tak? If you have a card, maksudnya yang first statement dia contohnya, dia punya okay. Okay, so if you have the current password, okay, ayat saya tadi yang pertama apa? Yang pertama premise number 1. This is premise number 1. Premise 1. Okay, premise 1 dia tadi apa? If your first premise dia tadi, ayat dia yang pertama is if your CGPA, okay, CGPA okay, CGPA greater than 2, then, okay, this is ayat yang pertama kan. Then, dia punya conjunction kat situ, then, okay, then, if your CGPA greater than 2, then you can, okay, you can register 18 credit. Contoh credit. Okay. Okay, so if this true, then, and this is true, then premise yang kedua, okay, my CGPA, contohnya CGPA dia ialah berapa? Contohnya CGPA dia bagi tahu dia ialah 3.5 contoh. Okay, then as a conclusion, you can take 18 credit. Okay, nampak tak kat situ? Maksudnya kita nak buat sistem untuk pendaftaran subjek. Macam tu, kita buat syarat. Jika CGPA dia atas daripada 22 dan dia boleh daftar 18 kredit. Okay, so dia kat sini premise number 2 is Ali, Ali CGPA dia 3.5. So conclusion dia Ali can register 18 credit. Nampak tak kat situ? Okay, use P to represent you have current password, then Q you can log onto the network. Then the argument is P, then Q, then this is P, and as a conclusion dia boleh log to the network. Okay, so example 2. We know that when P and Q are propositional variable, the statement P then Q and P then Q is tautology. Apa maksud ni? Macam tadi tu kan, if you have the current password, then you can log onto the network. Maksudnya ayat yang pertama tadi P, premise 1, P, Q, right? This is premise 1. Okay, premise tu apa tadi? Dia ada Q pula. P, dia ada current password, betul? Dia ada current password. Then conclusion dia Q. Q is tautology. Yang ni tadi yang page sebelum ni, maksudnya kalau kita nak represent dalam ayat, dia jadi macam ni. The statement dia akan jadi P then Q, dan kita gabungkan dua ayat ni dengan and. Okay, it will produce, yang ni kat sini is then Q ini ialah dia punya kesimpulan. Okay, what is tautology? Remember the last week class, which is at the end our answer will be all true. Okay, for example this P then Q. Okay, kalau P then Q and P, maksudnya kalau P then Q, tengok balik. Kalau then maksudnya dekat mana yang dia false. Bila dia ialah P then Q, maksudnya bila dia true then false, it will be false. Yang lain semua dia akan jadi true. Okay, so sekarang kat situ kalau kita nak cuba yang ni, kita ada P, kita ada Q, kita nak buat truth table dia kan? Okay, so sekarang dekat sini kita ada P, kita ada Q, macam ni kita buat truth table. Okay, so kita buat warna biru kat sini ialah true, false. Kat sini ialah false, then true, dan akhir sekali is false. Okay, so that here, saya ingat. Okay, so sekarang dekat sini kita nak create truth table, nak tahu dia tautology ke tidak. Okay, kita boleh cuba. Okay, kita ada PQ. Okay, yang pertama kita cuba selesaikan untuk yang dalam ni. P then Q. P then Q. Okay, P dan Q kita tahu bahawa dia akan jadi false dekat satu keadaan je bila true false. Okay, yang ni akan jadi false. But yang lain akan jadi true. Yang ni saya dapat kat mana? True, 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 false, false. False, true dia akan jadi true. Yang ni kita refer kat truth table yang minggu lepas tu. False, false juga dia akan jadi true. Okay, so table yang ni kita selesaikan pula yang keseluruhan ni, which is P dan Q, P dan Q and P. Okay, kat sini dia akan jadi apa? P dan Q and P. Okay, jadi kat sini yang ini bersama dan P. P kat sini. Okay, so kamu nampak tak? Yang ni yang pertama. Yang ni yang kedua. Okay, so kat sini bila dia ialah N ni, nampak tak? N must be all two true, must be true, right? Okay, so now it will become dua-dua true baru jadi true kan? True. Kat sini yang ni true, kat sini true, so dia akan jadi true. Mana lagi yang true? Kat sini false, kat sini true, akan jadi false. Yang ni true, false akan jadi false. Kat semua kat sini is false, false, false. Okay, so lastly, we have to find all the complete the truth table for this by using okay, yang ni semua. Maksudnya kita ambil yang ni, lepas tu then Q. Okay, jadi kat sini saya tukar color. Yang ni akan jadi our first argument, kan? First, lepas tu then, kan? First, then Q. Then Q. Q is here and this is our number 2. Okay, ingat then dekat sini refer dekat true table bila dia true false dia akan jadi false. Okay, kat sini ada true false tak? Okay, ni yang pertama. Ni yang kedua yang kita kena tahu. Okay, kat sini ada true true, false false, false true. Yang ni nombor 1 tau. Okay, false false. Dia tak ada pun dalam keadaan true false. Jadi dekat situ jawapan untuk semua ni saya wakili dia sebagai star. Ni semua ni dia sebagai star, dia akan jadi apa? Dia akan jadi true, 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 true. So we can conclude that this statement, this whole statement is tautology. Tautology because of the answer is all true. Semua benar. Okey, faham Kalau tak faham, saya minta saya ulang kat dalam tutorial lah. Okey. So sekarang dekat sini, okay, example 1. Okay, in particular, we both P then Q and P are true. We know that Q must also be true. Okay, we say this form of argument, so bentuk macam ni is valid. Because whenever all its premise or statement in the argument other than the final one, the conclusion are true. The conclusion must be also true. Okay, what happened? We replace P and Q in this argument formed by proposition where not both P and P dan Q are true. Macam mana kita nak, kalau kita jadi apa? Okay, boleh buat truth table tu. Okay, so consider example number 2. Okay, here. If you have access to the network, then you can change your grade. Okay. You have access to the network. You can change your grade. Ni ayat yang tadi tu. Ayat ni, kalau kita ni. Use P to represent you have access the network. Then Q to represent you can change your grade. Okay, sebenarnya dari segi etika logik ni kita dengar ni dia macam yelah mana boleh change grade sesuka hati, betul tak? Okay. You have access to the network. Okay. P is true. Okay. But P then Q is false. Tak boleh. Salah. Okay. False. The argument we obtain is valid argument, but because one of the premise, namely first premise ni tadi is false. Okay, hence we cannot conclude the conclusion is true. Okay, jadi kat atas ni dah false. Jadi dia akan jadi kita tak boleh conclude the argument is true. Semua tu akan jadi kita tak boleh conclude dia sebagai benar. Okay, rule of inference. For proposition logic, since using the truth tables is tedious approach, we can establish the validity of some relative simple argument form by using rule of inference. The rule of inference can be used as building block to construct more complicated valid argument form. The tautology, okay, this is the one example of tautology, which is this is premise 1 P and P then Q, premise number 2, it will conclude Q is the basis of rule of inference. This is the rule of inference. We call it as modus ponens or law of detachment. This tautology leads to the following argument. Inilah modus ponens tell us that if conditional statement and the hypothesis of this conditional statement are both true, then the conclusion must also be true. Okay, determine whether the argument give here is valid and determine whether its conclusion must be true because of the validity of the argument. Okay, here. Determine whether the argument give here is valid and determine whether its conclusion must be true because the validity of the argument. Okay, let P the proposition P. Okay, jadi sekarang kita let this is as P. Maksudnya P dan Q ni akan jadi P dan Q. Okay. The premise while the conclusion is Q. Okay, here is Q. Conclusion here ialah Q. Okay. 2 lebih besar daripada 9/4. Betul ke? Okay. So sekarang jadinya sekarang dekat sini kita tahu bahawa square root of 2 is what? Square root of 2 is 1.4. Square root of 2 is 1.4. And here 3/2 is equal to what? 3/2. 3/2 is 1.5. Okay, so we know that the first P is false, right? Then here 2 is greater than then yang ni pun akan jadi kuasa 2 besar pada kuasa 2 ni pun akan jadi false. Okay, then here the jawapan ni square root of 2 is false also. Then our final answer is also false. Okay. The premise of argument P and Q while the conclusion is Q. This is valid argument since it is constructed by using modus ponens. Okay, dia construct by using modus ponens. But however, its premise here, first premise P is false. Consequently, we cannot conclude the conclusion is true. Furthermore, note that the conclusion of this argument is also false because of here. Okay, we have to determine one by one in order to get the conclusion. Okay. There are many useful rule of inference of propositional logic as shown is in this table. Okay, here ini kita panggil sebagai modus ponens. Kalau dia bentuk dia macam ni, kita boleh represent premise 1, premise 2 and this is the conclusion. Conclusion must be always at the end kat situ. Macam ni juga. Yang last kali is conclusion. This is premise 1, premise 2. Premise 1, premise 2. Semua premise ni disambung dengan N. Okey. Dan kita kena ingat modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. Bila dia ada premise macam ni bentuknya, kita tahu bahawa kalau ni true, maksudnya dia akan jadi, last kali akan jadi, kesemuanya akan jadi true, tautology. This is bersifat tautology. Yang ni semuanya bersifat tautology. Last kali truth table dia, all answer must be true. Okay, so ni ialah rule of inference. Kalau kita nak conclude satu-satu tu, kita boleh refer ni. Dia guna modus ponens ke, modus tollens ke. Okay, so this is the sambungan, which is addition, simplification, conjunction, and resolution. Okay, so for this, where there are many premises, several rules of inference are often needed to show that an argument is valid. Okay, example 4. It is not sunny this afternoon and it is colder than yesterday. Okay, so sekarang your task, bila kita dapat ayat macam ni, kita nak buat dia dalam bentuk rumus yang ada premis tu. Okay, so sekarang kat sini kita kena tetapkan. Okay, sekarang dia cakap, dia kat sini dia kata P. This is P. Okay, P. Diwakilkan. It is sunny this afternoon. P. Then, it is colder than yesterday as a Q. Q. Lepas tu ayat yang kedua, dia bukan ulangan yang atas, jadi kita kena wujudkan lagi satu parameter. We will go swimming. Okay, we will go swimming sebab yang ni ialah penyambung ayat. Kita kena ambil satu-satu. We will go swimming as R. Then, S is it is sunny. Nampak tak? Sebelum ni ada tak ayat it is sunny? Tak ada kan? So it is will be parameter, next parameter, which is S. Mana it is sunny? Dah ada. It is P also. It is sunny, which is P. Jadi S ni kita next. We do not go swimming. We do not go swimming, we refer to this also. Go swimming. Then yang S ni ialah ayat yang tak ada dalam tu, which is will take a canoe trip. S and S. Faham ya? Macam mana kita nak wakilkan parameter ni? Okay, then if we take a canoe trip ni dah ada ayat sebelum ni. So, kita tak nyatakan dia sebagai T. Then T tu is will be home by sunset. Okay, we will be home by sunset. Sunset is T. Okay. Then, the premise become, okay, ayat yang pertama. It is not sunny this afternoon. Okay, ayat yang pertama, and it is colder than yesterday. Sambungkan P dengan Q ni. Okay, so sekarang kalau P kita wakilkan sebagai it is sunny. So, ayat kat sini, it is not sunny will be not P and Q for the first statement here. Macam tu. Faham ya? Okay, so sekarang first statement yang ni, yang pertama ni, dia akan jadi apa? Yang ni. Okay, dia akan jadi, ni ayat yang pertama, dia akan jadi yang ni, not P and Q. Okay, berdasarkan parameter yang kita wujudkan kat bawah ni. Then R, we will go swimming. We will go swimming only if it is sunny. Okay, it is sunny just now is P. We will go swimming is R. Jadi R then P. Okay, so ayat yang kedua, if we do not go swimming just now is our R. Then do not go swimming, not R. Then we will take a canoe trip. Canoe trip is S. Okay, then last sentence is, which is our conclusion. Conclusion tak? Okay. Yang ni, sebelum conclusion tu, if we take a canoe trip, then we will be home by sunset. Canoe trip. Canoe trip just now is, if we take a canoe trip as, then we will be home by sunset is T. Okay, jadi kita ada berapa ayat kat sini? 1, 2, 3, 4. Okay, nampak tak kat sini kita ada 1, 2, 3 dan 4. And this is our conclusion. We will be home by sunset, which is T. Okay, so sekarang dekat sini kita tahu this is first premise, premise number 2, premise number 3, premise number 4, then this is our conclusion. Okay, now what we are going to do? Then we need to give a valid argument with premise. Semua premis ni, yang ni ialah dia dapat daripada yang sebelum ni, ayat tu. Okay. So dia tulis balik premis tu, dan kita akan dapat conclusion T. Okay, so sekarang your task is, premis kita tadi yang mana? Okay, so sekarang this is the first premise, second premise, third premise, fourth premise, and this is our conclusion. Okay, so now we have to kaitkan. Macam mana nak kaitkan premis pertama dengan premis yang kedua or premis yang ketiga to get conclusion T. Okay, kita tengok cara dia ni dia punya example. Okay, it's quite difficult to understand, but once you get the technique, then it will be easy for you. Okay, premise 1. Okay, it use simplification using 1. Okay, simplification. Refer to the here. All rule that we want to refer is from this table. Modus ponens ke apa ke kat sini is simplification. Dia guna simplification yang pertama tu. Dia guna simplification is dia dapat P. Okay, nampak tak? Yang pertama, not P and Q, dia dapat not P. Okay, simplification by using 1. Okay, refer balik table tu ya. Okay, so now here number 3. Ini ialah premis daripada ayat tu. Okay, so sekarang nak kaitkan yang kedua dengan yang ketiga ni, dia guna modus tollens. So then, dia dapat yang keempat. Okay, yang not P, lepas tu R dan P guna modus tollens, dia akan dapat not R. Okay, refer balik modus tollens tu sifatnya macam mana. Okay, yang ni kalau tak faham nanti dekat dalam tutorial saya bincang balik Okay, so sekarang untuk yang ni, premis yang ni memang dah ada yang kelima ni. Okay, so sekarang nak kaitkan yang keempat dengan yang kelima. Keempat dengan yang kelima. Okay, kat sini dia guna modus ponens. So that yang keenam dia dapat S. Okay, so after we get an S here, then our premise is S dan T. Okay, kalau S kat sini S dan T, dia refer dekat modus ponens. So dia dapat T. So this argument is valid. Okay, so this is the example 5. Ini ialah dia punya contoh kontrapositif apa semua tu lah. Ini pun saya akan bincang dalam tutorial nanti. Okay, saya rasa sebab saya rasa saya untuk dapatkan lebih pemahaman. Okay, so now introduction to proof. Okay, so you can read this. The method of proof are important not only because they are used to prove mathematical theorem, but also for their many application to computer science. This application include verifying the computer program are correct, establishing the operating system are secure, making inference in artificial intelligence, showing that system specification are consistent. Okay, consequently, understanding the technique used in proof is essential both in mathematics and in computer science. Okay, proof like a jigsaw puzzle. There are no rule about the jigsaw puzzle must be solved. Okay, terpulang dekat kamu macam mana nak selesaikan untuk jigsaw puzzle kan, yang mana dulu, yang mana kemudian kan. The only rule concern is product, final product. Okay, the same hold for proof. Macam tu juga untuk proof. Okay, mathematician usually state the answer to mathematical question in the form of theorem that say that if certain assumption called the hypothesis of the theorem true, then some conclusion must be also true. Okay, example here. Example 6. Consider the following theorem. Suppose that x is greater than 3 and y is less than 2. Then x squared minus 2y is always greater than 5. Okay. This theorem is correct. The hypothesis of the theorem x is greater than 3 and y is less than 2 and the conclusion is here. As an instance, the theorem we could plug in 5 for x. Contohnya, kita nak letak x tu sebagai 5 and 1 for y sebab dia lebih besar daripada 3 kan. Jadi kita boleh letak 5. Lepas tu Y ni kita boleh letak 1 sebab dia less than 2 just now. Sebab ni selagi dia benar, maka yang ini juga benar. Okay. Clearly with this value, yang ni, okay, sebab X tadi 5 sebab dia sentiasa lebih besar pada 3 dan Y kita ialah 1 sentiasa lebih kecil daripada 2. 2 tu benar, kita ikut syarat dia. So the theorem tell us the conclusion ni also true. Okay. Certainly kalau kita masukkan X ialah 5, so dia ialah 5 kuasa 2 ialah 25. Tolak dengan 2 kali 1 ialah 2. Dia akan dapat 23 is always greater than 5 is also true. Note that this calculation does not constitute a proof of the theorem, just counter example. A proof will have to show that all instances are correct. Okay. Okay, this you can write. You can read by yourself. Then basic proof strategy. Okay, to prove a conclusion, kalau kita dapat conclusion macam ni P dan Q, kita kena assume, kita kena prove dengan assume P tu ialah benar. Lepas tu prove lah kita punya Q tu benar ke tidak. Okay, macam tu juga P dan Q ni assume P true dan prove Q. Okay. And same goes to prove goal. P dan Q is false, prove that P is also false. Okay. Example 7, if you have here, suppose A and B are real number. Prove that, okay, 0 is less than A less than B, then A square less than B square. Okay, so sekarang kita dapat kenyataan kat sini. A, B ni real number. Okay, we given a hypothesis that A, B are real number. Okay, kita dapat hypothesis yang pertama, real number. Our conclusion have the form here, which is P then Q. This is our P, then Q. Okay, P is the statement here, and Q is the statement here. A square is less than B square. Thus, we start this statement as given, and this is statement given, and this is our goal. Then, according to the proof technique, we should assume that this and try to use this assumption to prove that this, to become this one. In other words, we transform the problem by adding this statement to the list of given and making this our goal. Okay, this is as a given and this is as our goal. Okay, given and this is our goal. Okay, so now which is A, B real number. Then it gives another rule here. 0, A is greater than 0 and B is greater than A. Okay, and this is our goal. Okay, now comparing the inequalities, A less than B, then A square is less than B square, suggests that, okay, multiplying both sides by A or B might get closer to our goal because we are given A, B are positive. We wouldn't need to reverse. Okay, so here it will become what? Okay, so sekarang kita ada macam ni. Okay, so A, B real number. Okay, okay, so now we have what? A is less than B. Okay, from here, A is less than B and is real number. Real number. So we know that A is sentiasa greater than 0, right? So first, cuba darab semua ni dengan A. Dia akan dapat apa? A kuasa 2 lebih kecil daripada B, A, B, right? Dan yang kedua, A is less than B. Cuba darab semua ni dengan B. Okey, dia akan dapat apa kat sini? A, B is less than B square. Okay, so here, from here, Ni kita ada AB, kat sini pun kita ada AB. So kat sini dua-dua ni yang pertama ni dengan yang kedua ni kita boleh sambung tak? Maksudnya dia akan jadi apa? A kuasa 2 is less than AB. Nampak tak? Dua-dua belah ada AB. And it will A kuasa 2 less than AB. Dan sekarang kat sini B square tu is greater than AB. Betul tak susunan dia tu? AB ni tengah-tengah. Okay, so now kita boleh conclude that A kuasa 2 is always less than B kuasa 2. Okay, kat sini. Ni dengan yang ni kan. So we get our goal here. Okay, nanti ada soalan tutorial macam ni kita buat. Okay, so theorem. Suppose AB are real number, then A square is less than B square. This is how we prove just now. Okay, then after this we will go for set. Okay, thank you. If you have question, please ask in our tutorial session next week. Next week, inshallah, in tutorials, there is tutorial session to make you more confident with the lecture 2 here. Okay, thank you. Assalamualaikum. Good luck.